So we're looking at here is page 78, number 6. You have an equilateral triangle. So it starts off, and I'll go ahead and put this, but it starts off in the first picture is just, that's a bad triangle. But that is our first triangle if it wasn't thrown against the wall somewhere. Okay, so that would be our 0 triangle. Our first triangle is taking the triangle, and then you take the midpoint of each side, and then you paint just the middle. So this is our first 0 picture. That's our first picture. And then our second picture,
I only drew one picture. So.
It's okay, I'm just drawing them all just so we get an idea, because we're going to need these. Our second picture, you take the first picture, and then you do another set of triangles. You paint that middle triangle. So that's our second picture. And then our third picture is this one up here. That's 3. Okay? Now we have to be very careful about what they're asking here. It says, let P of n be the area that was painted during the step. So what that means here, it's not the total. For the P of n, it's not the total. It's just the number of the percentage, the fraction that was painted during that step. And then U of n is the total unpainted area after the step has been completed. So understand that first part. Okay, let's go ahead and go through all of these. So start with our U's. And they want you to find U1, 2, 3. So let's start with U0 though. And I'll just do this. I'll go, here's each step. And 3 is up there. So U0, this is a unit triangle, which means it has area of 1. Okay? So on this very first picture, how much of that is unshaded? All of it. So the actual answer for U of 0 is just 1. That is our starting point. The fraction of it that is unshaded, that is left unshaded, is the whole thing as 1. Okay? U1, U sub 1. After the first step, how much of that triangle is left unshaded? 3/4. It was divided up into fourths, and then 3/4 of it's unshaded. Bless you. U2. U2 is how much is left now unshaded. If you just look at these little triangles out here, what are these? What fraction of it is one of these triangles? 16ths, because you have 4 here, you got 4 here, you got 4 here, and the middle one could be divided into 4, right? Mm-hmm. So that's 16ths. So out of the 16ths, how 9 are unshaded still? Are we okay with that? And then U3, we can do the same idea. This is 4. 4, 4, 4. So this corner right here is 16. So what are these little triangles?
The unshaded ones?
Yes.
27.
There's 27 of them out of how many?
64.
64. So perfect. So it's 27 out of 64. So there's 27 unshaded, and those small triangles are in 64ths because there are 4 16s. Okay? Everybody okay with that? All right, let's do P of 0. P of 0, how much of this triangle is painted during that step? None. So P of 0 is 0. P of 1, how much of the triangle is shaded after that step? 1/4. Now we got to be careful because it's not really asking how much is shaded after the step. It's asking how much was shaded during that step. So during this step it was 1/4. But the next one how much is actually shaded during this step? Well, this middle is already shaded.
So 3.
3, and then it's still in sixteenths, right? So 3/16. Perfect. And then u of 3, how many were shaded during that step? Oops, not u. It would have been p sub 3. How many were shaded during that step? 9. These little ones right here. There's 9 of them. So 9 were shaded during that step out of the 64. So there are your u of 1, u2, u sub 3, and then p sub 1 through 3.
Wait.
Yes?
You might want to start. This cut it up.
Okay, now we're looking at B here. Write a recursive description of u sub n in terms of u sub n minus 1. So, hopefully we remember what a recursive description is. What is a recursive description? You use the previous term to give you the next term. So, if we thought about what u sub 0 was, and I'm going to go back, u sub 0 was 1. U sub 1 was 3/4. Double check me on that, please. U sub 2 was 9/16. And then u sub 3 was 27/64. So to do a recursive, you could just say it out loud first before you do the notation. What are you doing to get from to each term? That's how you do a recursive. What do you actually do to get from term to term? Multiply by 3/4, right? And that's it. It's the only thing that happens from term to term is multiply by 3/4. So to get your description, what you do is you say, and this is your notation part of it, you say, I take u sub n. To find u sub n, I take 3/4 times my previous term, which is u sub n minus 1. That's your formula for recursive. It's just the notation is tough. You're just taking, again, this means previous term, this means the current term. Previous term times 3/4 gives you the current term. You do have to tell it where it starts. So you'd say, okay, you start u sub 0 equals 1. And now we can create the whole sequence. So if I just saw this, what I would say is, okay, my 0 term is 1. I multiply by 3/4, so my next term is 3/4. Multiply that by 3/4, so the next term is 9/16. Multiply that by 3/4, the next term is 27/64. So I really think that the recursive, the only thing with recursive is that it's just the notation and how it looks. It looks really complicated. Okay, now if we were to find the explicit, formula, okay, what kind of sequence is this? I hear everybody whispering it. You're right. It's geometric. It's a geometric sequence because you're multiplying by each one. So now we go back to making our equations for geometric sequences, which are just exponential sequence or exponential equations, right? So if I'm doing a geometric sequence equation, and I have my sequence being here, where's my starting point? What's my starting term? 1 times, oops, I better be a little bit more formal about this. I should say u sub n equals 1 times 3/4, perfect. And then what? Up to the n power. That will work. Just double check that it works. If I plug a 0 in, 3/4 of 0 is 1 times 1 gives me 1. I plug a 1 in, 3/4 to the first power is 3/4 times 1 is 3/4. That works. Somebody last period came up with the idea that what if you did this? What if we did u sub n equals 3/4 times 3/4, but now I'm going to go n minus 1. Does that work? That also works. If I plug a 1 in here, 1 minus 1, 0. 3/4 of 0 is 1. You get 3/4. That works. It just shifts it up. Okay, we kind of had that on the last test. What if I wanted to put this number as 9/16? If I made this starting number 9/16, how would that change my exponent? It'd be n minus 2 instead. Okay, so we have that option. I just think it's easier just to make it like that. All right, so that is your explicit formula for u sub n. Okay, a reminder here is that we're looking at a description of P sub n, and P sub n was the area that was painted during the step. So we have to be a little bit careful because it's not the total amount painted. So if we go back and try to remember what we did here, P of 1 would be the amount that was painted in the first step. The amount that was painted in the first step was just this middle triangle. Okay, so how much of that is painted in the first step? 1/4. The second step, I'll do a different shading just so you can see the difference here. The second step is how much of it is painted in just this step. There are these next size triangles. How much of it was painted during that step? 3/16. And then P of 3 was painted during the third step, and that's all these little ones here. So how many were painted, what percentage is painted during that? 9/64. You guys are catching right into it. 9/64. So, how we know that is because, well, you got this 1/4, right? Did you get the 3/16 one, where that came from? Well, if you look at this, we're just looking at just maybe this corner right here. There are 3 there that were painted out of, there's 4 here, 4 here, 4 here, and there could be 4 here. So that's 16. So there's going to be 16 in this corner.
Times 4.
Times 4 is 64.
16 that are painted? Or
No, just 16 total. There's 16. It's broken up into 16ths there, so it's 64 overall. All right, so we have those. And we want to come up with a recursive description. Recursive, you need 2 things. You just need where it starts and what happens between each step. So what's happening between each one of these steps here? To get from there to there to there? Times 3/4. So you could verbally say your recursive description. Your recursive description is you're starting at this, P of 1, or P sub 1, is 1/4. You're starting at that, and then you multiply each one by 3/4. That's a recursive description. To write it, you just say, hey, I start at P of 1, P sub 1 equals 1/4. And then what I do is to do any P of n, P sub n, I take 3/4 of my P sub n minus 1. And what this means is that, and again, this is just a notation for what we're saying here, is any term is 3/4 times the previous term. So if we know where to start, we just multiply by 3/4 and we can get each term.
So it's not just an equation?
No, that's the whole thing. You need the starting point for recursive and you need the equation.
Okay.
Now the explicit formula that we need to find. The explicit formula, that is where we want a formula where we can plug in a 1 and get a 1/4. We want to plug in a 2 and get 3/16. We want to plug in a 3 and get 9/64. So we want to be able to plug those numbers in. Okay? So whenever we do this, first of all, what kind of sequence is this?
Geometric.
It's geometric, perfect. It's a geometric sequence, so that means we want to have a starting point and your multiplier. We already have that. Our starting point's 1/4, and our multiplier is 3/4. So I would say, okay, the explicit's 1/4 times 3/4. You have to be a little careful about what their power is. If I want to be able to plug a number in here I'll start with n. Make sure when I plug a number in there, 1, I get 1/4. There's a problem with this, yeah, because if you plug in a 1 here from this p of 1, you don't get 1/4. You get 3/16. So you do n minus 1, and that's because we started at the first term. So now when I plug a 1 in here, I get 1 minus 1, 0. 3/4 of 0 is 1, and that's 1/4. So that works for your explicit. Cassie?
Why do you put 1/4 in front of the 3/4?
Because that's my starting point right here. Almost like your y-intercept in a way.
Why did you start at P1 for this one, but on the last one we started with U of N?
Well, on the other one we started at u0, right?
N. That I have.
Like in the explicit answer, U of N.
Yeah, u of n. Oh, yeah, so yeah, it should be written, I'm sorry. It should be written, the explicit should be p sub n equals that. That would be your actual explicit formula right there. The only thing you have to be careful of is if we start at a 0 sequence, plug in a 0 in, then typically we're not going to have this minus 1 at the end. That minus 1 occurs because we started at the first term, p sub 1, and that's why we put the minus 1 there. Okay, this one says, use your work to evaluate the sum 1/4 plus 3/16. So basically we're taking the sum of that last sequence, so which would be a series. Okay, so we already had our explicit formula. It was 1/4 times 3/4 to the n minus 1 power. Okay, I could write this in sigma notation, so I'm actually going to do E right now, and we're going to combine that with D here. So if I do sigma notation, it means I want to sum up the series formed by that formula. Where am I starting at?
Wait, what happened to letter D?
We're going to E first.
1/4.
I'm starting at 1/4, but what's the first thing I'm going to plug into my equation right here? 1. Because if I plug a 1 in, I get my 1/4. So the first thing I'm going to start at is my 1. And now we look at our formula here. Their formula is a little bit different than our formula, but we're still going to be okay. My last term, I want it to be to where I plug in a number and I get 100 here for the 3.
101.
So that'd be a 101 we're going to go to. Their formula is a little bit different. Okay, what their formula they're using here is 3/4, and then you have to the n and then the n plus 1. I don't like that way so much. You can see how it's going to be the same thing because of that 1/4 in front.
What if
So-
they would have just had the number like 3 to the 100 power? What if they would have just had that answer? And how would you have known what n would have been?
The n would have been 100, and we put that there. Okay, so the main thing here is that when you do the formula, the longhand formula for solving this, you can actually type this in your calculator, and you'll get an answer. Okay, so if some of you or a few of you could start doing that know how to do it in your calculator, you just go to, I think it's math, and then down to 0, which is sum. You'll get an answer for that. Okay, but longhand, without that calculator notation button, what you would do is you take your, and we've done this fraction before, 1/4.
Wait, on that purple part, is that all to the n power?
No, just the 3 is.
So I don't get that part. Where did you get?
You don't need to worry about that. I was just saying that that's what they used. I used that formula, so I'm going to use that formula. Yes?
I think the purple formula is correct. I think it'd be 3 to the n minus 1.
So you're going 3 to the n minus 1 here.
Yeah, because if you use that formula and you plug in 1, it would work.
Right. If we did the n and the n plus 1, you'd have to plug in a 0 first, and then you'd be off by 1. Okay, I don't want you to get too lost in this right here. Okay. then don't look at this. Don't look at that.
I was gonna say that one was wrong.
Okay, what I'm saying is this formula works.
Yeah.
This is the formula that we're using. We constructed this formula. Use that one.
What letter are we on?
We are doing D and E at the same time. I already did E
What's next?
because you need both, and you don't need to have one before the other.
Clever, Maggie.
Thanks.
Okay, so back to our formula. To do this by hand, I'm using my explicit formula right here. Okay. Now, the power is how many terms there are that you're adding up. So, how many terms am I adding up between 1 to 101? 101, right? So your power here should be 101. Okay? Minus your very first term. Your very first term would be 1/4. We already have that. And what goes in the denominator all the time? Yeah, 1 minus, or 3, the parentheses minus 1. So that'd be 3/4 minus 1. Now here's the good news about this. Because this is a fraction, and this number is big. I mean, 100, if you do it at 100, you keep on adding. This number right here, this last term, is really, really small. So your decimal is only going to be off by a touch if you put 100 here or 101. Okay? In fact, the answer, did we do that as a calculator already? So you have 0.75. Okay?